Good morning. Today morning, this phi consists of the five element function. The first one it will convert the mnemonic code into machine language code. Second one, symbolic operand to equal machine address. Third one, without find out the proper instruction format. Fourth one, convert the data constant into internal machine representation. And last one, we are going to write the object program and the assembly listing. Next, we are going to take care of further reference problem. This is the important thing. With the help of this further reference problem only, we are going to take care of assembler algorithm and data structure. Now, what is further reference problem means? Whatever the symbols or identifier appeared in the operand part, that symbol will be defined later in our source program. That is called as further reference problem. In this program, this is assembly level language program. This is our label part. This is our opcode part. This is our operand part. In this part, the start is our starting. Here itself, the assembly level language program will be started, and the equivalent label part is called as copy. This is our program name, and equivalent operand part is called as 1000. This is our starting address. Then what is our first executable instruction? That means second line. What's the second line here? First. First is called as our first executable instruction. At the end of the program, n will be there. Up to this, these are all the machine codes. Assembly level language code is available in our further reference problem. Here, return address. The second line, it consists of the operand is called as return address. This return address is appeared in the operand part, and the equivalent label part is defined in the 96th line only. But it will be defined 10th will be required. Then this problem is called as which one? Further reference problem. To avoid this problem only, we are going to take care of two algorithms. This is called as assembler algorithm and data structure. The first one is pass1, second one is pass2. Pass1 always it scans the entire source program for label definition and assigning address for each and every symbol. Second one, perform actual translation. It will construct the object program. Object program consists of object code. Object code will be represented by three records: head record, text record, end record. This is the format of object program. The first one is column 1 is head record is represented by head. Second one, column 2 to 7 program name. Column 8 to 13 starting address. Column 14 to 19 length of the object program. Then text record, column 1 represented by T, that will be text record. Column 2 to 7 starting address. Column 8 to 9 length of the object code. Then column 10 to 69 we are going to write the object code. Then end record we are going to write column 1 E, column 2 to 7 address of first executable instruction and hexadecimal. Then two passes are there. The first one is pass 1, second one is pass 2. Pass 1 we are going to define the symbol. Pass 2 we are going to take assembly instruction and generate object program. This is the algorithm and data structure we are going to take care. Assembler we are divided into two categories. The first assembler algorithm is called as pass 1. Second assembler algorithm is called as pass 2. Pass 1 take input as two things. The first one source program and the optape. And it produce pass 1 is output is called as three outputs. The first one intermediate file. Second one location counter. Third one symbol table. And pass 2 it will produce input as all the input and output of pass 1. That means source program, intermediate file, location counter, optape, symbol table. It will generate the output is called as object code. Then object code will be represented in terms of three records: head record, text record, end record. Then these are all the data structure that will be defined in a table. Location counter is one table, optape is one table, symtape is table. These three tables are said to be data structure in a source program of assembler algorithm and data structure. Then this is algorithm for pass 1, this is algorithm for pass 2. We can execute one by one. Then we are going to take the element one by one. Then consider this is a source program. We are going to write one by one. Now what is we have start? Our first execute instruction first. We'll check it. Whatever the symbols, whatever the opcode will be identified. First we can identify symbols. What is symbols here? Whatever the label part we can find in our source program, that is called as our symbol. What are the symbols here? First, then C loop, then N fill, then VOF, then 3, then 0, then return address, then length, then buffer. These are all the symbols. Then second field is called as opcode. This opcode field consists of only the assembler directive or instruction set used in the SIC or SIC/XC machine architecture. Then this is the operand. What this opcode we are going to perform, we are going to make the operand. Then First, we are going to execute pass1 algorithm. What does pass1 algorithm mean? We are going to find out the location counter value. First one, search optape for opcode. If it is available, add 3 to the location counter value. Then if it is word also, add 3 to the location counter value. If it is reserved word means, add 3 into corresponding operand to the location counter value. If it is reserved byte means, add the corresponding operand to the location counter value. If it is byte means, find the length of the constant. How many constant is available, then you can add the corresponding length. This is the location counter value we have to find out. Then at last we are going to find out the length. How we can find out the length? Ending address minus starting address is called as length of our object program or object of our source program. Then we are going to represent which one? Object program in a pass2. Object program will be represented by object code. How we can write the object code? We are going to represent in terms of two mnemonics. The first one is mnemonics of the corresponding opcode and will be continuously adding with the corresponding operand part. That's why we are going to take corresponding object code. It will be represented by 3 records. The first one is called a set record. First one we are going to represent such. Second one 2 to 7 program name. Second, in this program, what is the program name? We are going to check it. What's the program name here? Copy. That we can represent in terms of copy. Then what's the third one? Starting address of the object program. We have to check it. What's the starting address? Here what's the starting address? 1000. 1000 we are going to represent in terms of 1000. The next one 14. 14 to 19. That is the next one length of our object program. The ending address minus starting address. That will be must be mentioning location counter value. That is for example 1A. Up to this header record gets over. Next one is text record. Column 1 represents T. Then column 2 to 7 starting address. What's starting address? 1000. Column 8 to 9 length of our object program. What is our object program length? Already I am telling 1A. Then 10 to 69 we are going to represent each and 6 bit each and every object code we are going to represent in terms of 2 or 3 more columns. The last record is called the end record. Column 1 is will be represented by E. Then column 2 to 7 address of first execution instruction. That is called as our starting address. Same what's the starting address is 1000. This is pass1 and pass2 of assembler algorithm. Thank you.